Hi, I'm Lucy, and in this video we're going to have a really quick look at how to add and subtract surds. You should already know how to simplify them, but if you've forgotten, watch this video first. There is just one simple rule for adding and subtracting surds. The square root number must be the same. And then you just treat it like an expression. You deal with the numbers outside the square root as one thing, and think of the number inside the square root as a letter. So what's wrong here? Can we subtract these? Nope. Square root 5 and square root 3 are different. Just like 10a take away 7b can't simplify, nor can this. But be careful, because you may be able to simplify the surds first, and then add or subtract. So give this question a go yourself. Simplify and then subtract. Pause the video, work out the answer, and click play when you're ready to check. Did you get it right? Square root 3. As always, simplifying is a really important part of surds. Give these questions a go. Pause the video, work out the answers, and click play when you're ready to check. Did you get them right? There is just one final piece of the surds puzzle, and it is known as rationalising the denominator. We'll have a look at that in another video. Hi, I'm Lucy, and in this video we're going to look at how to multiply and divide with surds. We've already looked at how to simplify them in this video, and now we're going to learn how to calculate with them. So let's jump straight in with an example. Can you see what's happening? You just multiply the numbers together to make a single surd. Easy! If you know how to simplify surds, as we saw in our earlier video, we now just work in the other direction. We multiply them together. So there's nothing new to learn whatsoever. Why do we do this? We need to sometimes multiply surds together, like the root 6 and root 3, so that we can then simplify them fully. Root 6 and root 3 are as simplified as they can be on their own, but root 18 can then be simplified down into root 9 root 2, which is 3 root 2. So that's multiplying surds. Now for dividing surds. Can you see what's happening? As with multiplying, you just divide the numbers. Here are some questions for you to do. Pause the video, work out the answers, and click play when you're ready to check. Did you get them right? You may have done different working to what I have, but here are some different options. So there we have multiplying and dividing with surds. We often combine these two skills with simplifying at the same time. So we've already discovered what surds are in this video and how to calculate with them in these videos. We're now going to look at the final piece of the surds puzzle, at what rationalising the denominator is. We know that the denominator is the bottom part of a fraction. So have a look at these. What do you notice about those that are rationalised and those that aren't? Rationalising the denominator is when we move a square root from the bottom, the denominator, to the top, the numerator. For a surd to be in its simplest form, the denominator cannot be irrational. It can't have a square root in its denominator. It's not wrong, it's just not considered the simplest form. Let's have a look at how we move the root. Multiply both the top and bottom by the root, and we get 1 multiplied by root 2, which equals root 2, and root 2 multiplied by root 2, which is 2, because the rules of surds means that we do 2 times 2, which is 4, and the square root of 4 is 2. You can check this yourself on your calculator. Type in 1 over root 2, press equals, and the calculator will rationalise it for you. But this won't get you marks in your exams. You've got to show the working, but do use it just to check yourself. So here's one for you to do. Rationalise this fraction. Don't worry about the 3, leave it where it is in the denominator. Pause the video, give the question a go, and click play when you're ready. Did you get it right? 5 root 7 over 21. So let's have a look at a trickier example. I'll do the first bit for you to get you started. We need to multiply by the whole of the denominator, but change the sign. So think of expanding brackets and the difference of 2 squares. We would get a squared plus ab minus b squared, and the plus ab and minus ab would cancel each other out, leaving us with just a squared minus b squared. This is exactly what we want to do here. We want to cancel out the surds. So expand the denominator brackets and what you get. Pause the video, work it out, and click play when you're ready. You should have got 11. So going back to the question, we can simplify by expanding brackets, and we get this, 12 plus 3 root 5 over 11. So give this question a go yourself. Pause the video, work out the answer, and click play when you're ready. Did you get it right? So there you have rationalising the denominator, which is just a fancy way of saying remove any square roots from the denominator. We have to do this to ensure that we fully simplified our surds.